Hi there, Laura from Equinix here, and today let's talk about load balancing. Load balancing is the act of distributing requests across multiple systems to ensure no one system is overloaded and responses are fast. Usually, when someone brings up load balancing, the context is load balancing in networking, where the requests come over a network to a single device that then routes the requests to different machines to process and reply. To understand load balancing, let's imagine a real-life scenario in a counter-serve restaurant. People line up at an order here sign, and workers behind the counter take orders. If we weren't worried about efficiency, we may have only one worker that takes each order, makes the food, and then rings up the customer at the end of the counter. A request, action, and response. In a busy restaurant, one worker taking care of the whole line alone will cause a long queue to start. Instead, let's add a load balancer, a worker that takes orders and hands it to the next available worker, keeping the line moving. Every request comes through that worker, but that worker does not actually process anything. They work as a conductor, keeping the orders flowing through the kitchen and to the payment counter, where the customer pays and receives their food. In this way, we can ensure the restaurant performs quickly and efficiently, and any order that takes longer than others doesn't hold up the line. You also can then rely on that restaurant to deliver food quickly. A load balancer does the same thing. It distributes the workload, or balances it, across multiple machines to ensure speed and reliability. Depending on what you're doing and where you're doing the work, the load balancer can be a physical machine, like you might find in a data center, or a virtual one in the cloud, such as a load balancer living on a virtual machine, or a serverless function acting as an application load balancer. Regardless of where the load balancer lives, it does the same basic function over and over again. There's multiple algorithms or step-by-step sets of instructions to distribute workloads in a load balancer. We usually split them into two different kinds, static and dynamic. Static algorithms don't know anything about the state of the servers running the workloads. They blindly dole out work based on what kind of server takes which kind of work. And they won't know how far each server is on a prior task. An example of a static algorithm is a round robin, where the load balancer sends requests down a list in order and restarts at the beginning when hitting the end. As you might imagine, while this algorithm might work under workloads where the tasks are fairly simple and fast and the incoming traffic is light, it doesn't work as well when you have heavy traffic and complex tasks. Dynamic algorithms, on the other hand, know about the state of the servers running the workloads. These algorithms could be able to tell, for example, that maybe one server is slowly failing, while another is brand new and working well. So it can send more work to the newer server and less to the one that's failing. This really comes into play when tasks coming in have varying levels of complexity or time needed to do the work, like one task being to load a page while another is a database update. These kinds of algorithms are great, but they are more complex to set up and maintain. And you need to know your systems better than you would for a static algorithm. One example would be a dynamic algorithm that sorts workloads based on geolocation. So the work is done closest to the request, which can avoid latency issues on your network. This is great and all, but what does it have to do with your day-to-day work? If you're working on any kind of distributed system that communicates with other systems, you're using a load balancer somewhere. If your software architecture uses microservices, you may need to think about how a load balancer needs to distribute those workloads to those microservices, or whether you need a load balancer between services to help scale your systems. When you're updating a production system, you're probably using a load balancer somewhere to deploy those changes in stages so you maintain uptime, or so you can test the change with real-life traffic, or to find out which change is more popular. There are so many ways that a load balancer is critical to the systems we work on. It's worth knowing how they work, so it's not a random box on a diagram or a recommended block in your Terraform code that you don't understand why it's there in the first place. This has been your Tech Explainer for this week. Please like, share, and subscribe. I'll be back soon with another explainer video, right here on Equinix Developers.